In this video, we are going to do a stochastic process example involving symbols. So these are examples that we draw tree diagrams for to represent probabilities and conditional probabilities. So this example says, if the probability of A is 0.4, the probability of B given that A happens is 0.16, and the probability of B given that A complement happens is 0.7, find the probability of A given that B occurs, and round to 3 decimal places. So let's think about this using a tree diagram. So I'm going to draw a section for where we will begin. And I'm going to represent this with 2 stages. One stage for whether or not A happens, and one stage for whether or not B happens. And because both of the probabilities that I'm given, the conditional ones that I'm given, say given that A occurs, or given that A complement occurs, I'm going to talk about A first. So I'm going to put A or not first. And when I write that, I mean, okay, when we begin, well, either A happens or A complement happens. In other words, A does not happen. Okay, and then after that, I'll talk about, well, does B happen or not? And then we could talk about the outcomes, and finally write the probability. Okay, so from each of these first stage outcomes, either B could happen or B complement would happen. Same thing here from A complement, either B happens or B complement happens. And then I can write my outcomes. So my first outcome is AB, and then it's AB complement. Then it's A complement B, and finally A complement B complement. Okay, and now let's see if we can label some probabilities here. So the question does say at the start that the probability that A happens is 0.4. So we can label that along this A branch, 0.4. But that must mean that the probability that A complement is 0.6, because those two got to add up to 1. Okay, so let's look at the conditional probability that B happens given that A occurs. So that is going to be, starting with the A branch, given that A happens, the probability that B then happens is 0.16. So 0.16 here. And then for this other conditional probability, this is given that A complement happens. So we're down on the A complement branch. And it's the probability that, well, given that we're there, that B now occurs. So that would be going along this branch to B. And that probability is said to be 0.7. Okay, so based off of this, I can fill out these 2 missing branches. So this one would be 0.84, because that added to 0.16 is going to be 1. Let me just put this in the margin to show, well, where did I get this? Well, it's 0.16 added to 0.84. They need to add up to 1. So similarly, this has to be a 0.3 because I need to be able to add it to 0.7 to get 1. Okay, and now we are ready to write out these final probabilities. So we're going to get 0.4. Here we'll get 0.4 times 0.16, and then I'll get 0.4 times 0.84, and then 0.6 times 0.7, and then 0.6 times 0.3. Running out of room here a little bit, so I'm trying to write this small. Okay, so I just scooched that over a little bit, and now multiplying. This first value is 0.064, then it's 0.336, and then 0.42, and that last one is 0.18. Okay, so let's write down our conditional probability that A given that B occurs. So the formula for this is the probability of A and B on top, and I divide by the probability of whatever condition we're given, the probability of B. Okay, so for the probability of the intersection of the two, well, that is this outcome right here, and here's that probability. So that's what I would write. On the top, I would write 0.064. Alrighty, so now let's do the denominator, which is the probability of B occurring. So there's two outcomes where B occurs. B occurs here in this outcome, and B also occurs here in this outcome. So I got to add those two probabilities together. So 0.064 plus 0.42. All right, and if I plug this into a calculator and I round it to 3 decimal places, we get 0.132. And that's our answer. So these tree diagrams can be very helpful in organizing multi-stage experiments like this, particularly for evaluating these conditional probabilities. So in terms of our goals for this section, we finished our second goal. Over the last few videos, we've shown how we can use tree diagrams to solve for conditional probabilities in word problems, as well as in a purely symbolic example like this one. In the next video, we will talk about how we can evaluate the probability of A intersect B when our two events are independent and when they are not independent.